Let's talk about the pulse wave. Let's leave the triangle wave and the square wave on. Let's add another oscilloscope. And let's patch our triangle wave and our square wave right here into it. Let me adjust the time so you can see it better. So these two waveforms are each symmetrical. What does this mean? You can see they are mirrored above and below the horizontal center line. It doesn't matter if they are in the positive or negative range of voltage. You can see both the triangle wave and the square wave remain symmetrical. They peak at the same frequencies. Now let's talk about the pulse width of the square wave. As you can see, the pulse width marked with PW here is currently at 50%. What does this mean and what is this pulse width? When the pulse width is at 50%, the waveform is square. This top part here is called a duty cycle, and when it's at 50%, it means the signal stays in the high voltage for half of the waveform cycle, and so the waveform is square and symmetrical. Now let's increase the pulse width to 80% and see what happens when the duty cycle is longer with 80%. And also this will affect our harmonic content. Now let's reduce this to 10% and see how short the duty cycle gets. You can see this peak here is very short now, just a 10% duty cycle. I can offset this waveform, which means I'm changing its baseline voltage level, but this does not affect its duty cycle. Let's go back to the square wave. So by modifying the square wave's duty cycle, we create something called a pulse wave, also known as rectangle wave, because it's no longer symmetrical, so it's no longer a square wave. Let's unpatch the triangle waveform. Let's see and hear how changing the pulse width looks and sounds like. And back to our square wave. So now you know the unique property of the square wave is the ability for its duty cycle to be modified, and this is how rectangle or pulse wave forms are created. You also know that a duty cycle is the ratio of the waveform when it stays in the high voltage compared to the cycle of the waveform. This may sound and look a bit boring for now, but it's going to be very useful when you start using pulse width modulation.